So what I have here is a table with a bunch of different points. We have our x and y values. We have x values of 1, 2, 3, 4, and 5, and then y values of 3, 5, 6, 5, and 6. Now, what I would like to demonstrate to you is how to solve for your line of best fit, for your gradient line, for your line of regression. There are many names for it, but essentially what we're going to need to do this is to find what x minus x bar is, and x bar is just equal to your average value. So as you can see on here, I wrote down your average values, and I've also represented it on, like, visually on the table on a graph. So we can see that I have our points plotted here. This is 1, 3, we have 2, 5, we have 3, 6, 4, 5, and 5, 6 here, and our x bar is equal to 3, so our average x value is equal to 3. Our y bar, our average y value is equal to 5, which is those two lines there. Now, if you fill in this table, which is pretty simple, you just fill in x minus x bar. So we have 1 minus 3, we'll get -2 and fill all the way down. Same thing with y values, but we also need to be able to find the x minus x bar squared, which helps us find the area of the distances from the points from the line. And we have 4, 1, 0, 1, 4, and then we'll also need to be able to multiply these two values together to get 4, 0, 0, 2. And what we need to do now essentially is to find our m value for our equation y equals mx plus b. And to find this, we need to sum up each of these values, and I've done that for you, just to save time. So we have 10 for x's, for x squareds I should say, and then 6 for the sum of our x's and our y's. And essentially what we're doing here, I'll write this out for you, is we're given an average m, or our average slope, which is 6 over 10. And what this is asking us is, what we also need to find out is, because of the x values, and then we need to find the b, we have y, but we're given two average x's and y's, so we can use those, just substitute those in. So our y value was 5, was 0.6, and our x value was 3. So multiply this by 3. Then we can use this to find where the line, the gradient, the line of best fit starts off on, and the y-intercept. So we fix this 5 and 3 for our x's and y's, and what b will be equal to is it should be 2.78 if you do the math correctly. If I did the math correctly too. But just to solve for our equation, to plug everything into our equation, we have y equals 0.6x plus 2.78 for our b. And then again, this is the slope and y-intercept. And then if we were able to graph this on our graph, then we see that around 2.78, around here, we should be able to draw the line through about here if it follows our same slope. And that makes sense to me, if it's the graph, or if it's our data points for our line of best fit. Now, what I'd also like for you guys to be able to find is the r value, which is the constant value that we worked on earlier. But in order to find this, I would recommend that you use your calculator, TI-84 or TI-83 TI anything. But essentially what you need to do is go to stat diagnostics and turn that on, and then that'll allow you to be able to view your different R values, your different coefficients. But then after that, you need to go to stat edit, and then this will give you a possibility to list your L1 and L2 values, which is your L1 is equal to your X values, and then your L2 is equal to your Y value. So this will be L1 and this would be L2, and then you plug all of those in, and then you go to stat calc, and then you press the number 4, and then this number is just a substitute for the word linear regression, and this should give you an R value of what we have here. It'll give you an R value of around 0.77. Now, I'd like to go over some problems for you guys just to make sure that you were working on all of these. So our first problem will be similar to our first example, and we're given 4 graphs. We have A, B, C, and D again, and then we're given different R values, and I'd like you guys to match these up together. But the trick here is that for the fourth one, we're given what graph it should be, which is D, but I'd like you guys to be able to give me an example of what number the R value should be around, and I'll give you guys some time to think about this. Just pause the video and then I'll share the answers for you. So for the answers, for our first one, we have an R equals 0. This should be letter C, and this is because of the fact that the X and Y points are, well, these points are essentially make a line straight across that has no slope, that has a 0 change, and I believe that's pretty evident here. And then for our second one, we have 0.12. That should be, you should have got letter A for that, because of the fact that this is very widely dispersed compared to the other 3, and even compared to this one, it's still more dispersed than A is still more dispersed than B. So you should have gotten 0.12, and then for B, you should be in your final one. You should have got 0.34, and for the fourth one, for D, you should have anything that is close to 1 or close to -1, because of the fact that, as you can see, that as X increases, Y decreases, so it should be a negative number for this. So an example of this would be -0.87, and that would work for this. And our final question, our final problem, will be going over what we did in 5.4 to find the line of best fit again. And what I'm going to ask you guys to do here is to fill out this table. I've already given you the X and Y values. Now what I'd like you to find are your X bar, your Y bar, which are again the averages, and then you need the sums as well. But then also fill out everything else in the table. Now, I won't give you the answers to these because I think they're pretty simple, but what I was asking you to find was your R value, and then your Y equals MX plus B again.